Measurement accuracy is a key aspect of science. This is true whether we're in the lab doing an experiment or if we're looking at applications such as pharmaceuticals. One way to show the accuracy of a measurement is to look at the number of significant figures in that measurement. Significant figures are the measured digits in a determination showing the accuracy of that measurement. Now, some measurements we know exact. An example of this is when we count. So for instance, on the screen we see 3 stars. This might as well be 3.00000 stars. We know exactly that there are 3 stars. These have infinite significance. Another example is conversions. For instance, 1 inch equals 2.54 centimeters. We know this exactly. But now, not all measurements we know exactly, and in fact, most cases we don't. So for this example on the screen where we have a measurement of a flask of its mass, the balance says it's 89.512 grams. It does not mean that the mass of this is 89.512000 grams. We only know these 5 digits. Now, when we have a measurement like this, typically we know all the digits fairly well, except the last one. This last one is uncertain. So we know with high accuracy that it's at least 89.51 grams. That last digit, that's a guess. In this case, from the balance. Now, let's go and let's compare this to another case. Let's say we had this measurement on the right, where here the balance is 89.5 grams. The measurement on the left, A, has a higher accuracy. We know it to more digits. Notice there are 5 digits here, whereas on the right there are only 3. Okay? So this shows us that we have more accuracy. Now, typically in measurements such as this, in order to get that high level of accuracy, more digits, it means that the equipment has to be a higher value and higher accuracy. So now let's look at measurements and see how we can tell based on numbers how much significance there are. All right, so one way to understand how many significant figures we have is by looking at what type of digits we have. So first, all non-zeros, that's 1 through 9, are always significant. So for instance, in this case, 34.8, all 3 of those digits are significant. So we have 3 sig figs. 1352, again, we have 4 significant figures. Zeros, it gets tricky, and really, for zeros, it depends on where that 0 is in relation to the non-zero digits. And so in this case, we can call zeros either captive zeros, leading zeros, or trailing zeros. Captive zeros are those that are between non-zero digits. So in this case, we have an 8 and a 2. Those are non-zero. And so this 0 in between, this is a captive 0. These are always significant. We then have leading zeros. These are in front of any non-zero digits. So you notice that these zeros, these 3 zeros here, they're in front of all the non-zeros, right? This one is in front, but it's also behind, right? So leading zeros are never significant. And then finally, we have trailing zeros. Trailings are behind or after all the non-zero digits. So in this case, it's this 0 right here. These are significant only if there is a decimal place in the number or decimal point in the number. So in this case, this 0 is significant because there's a period here. Let's look at this let's look at some examples. So let's say we have 21.8. In this case, all 3 of those are significant. So we have 3 significant figures. 21.08, these 3 are significant because they're non-zeros. And then this one is also significant because it's a captive 0. So we have 4. Here, we have 0.02108. The 2, the 1, and the 8 are significant because they're non-zero. This 0 right here is significant because it's captive. And these right here, these are not significant because they are in front of the non-zeros. They are leading zeros and they're not significant. So we have 4. 0.021080. Now this is the exact same as the one before. So this 0 is significant, these two aren't. But now this one back here, this is a trailing 0. And so in this case, it is significant because of this period right here. And so in this case, we have 5 significant figures, including this last 0. And then finally, 21080, or 21,080. In this case, the 2, the 1, and the 8 are all significant. This 0 is significant because it's captive. But this last 0, this is not significant. Why? Because there's no period. If this had a period here, it'd be significant. But in this case, there's not. So we have 4 significant figures.